When you go back to the first second, or the first thousandth of a second, or the first millionth of a second after the Big Bang, you find that the universe was extremely simple indeed. So our picture is that the universe has been expanding and cooling ever since it began, and getting more complicated. So things like you and me, and stars and planets and galaxies, these complicated structures that we see out there in the universe, are in a sense properties of an old and cold universe. Right? In a sense, they've crystallized out. But if you sweep back in time, the universe, well, that structure melts away as the universe gets hotter, and you find a very simple universe indeed, a universe that we can understand to a large extent. So the problem, the scientific problem in the spirit of Richard Feynman, is to do the following. We want to guess about how this structure emerged, and then we want to do experiments. But we want to do experiments back here. What we really want to do is build a time machine and sweep back to the first billionth of a second after the Big Bang or before, and observe what's happening in the universe. We can't do that, unfortunately. But what we can do is recreate those conditions in a lab. The conditions of very hot, very dense, very energetic space. And this is the lab that we do that at. It's called the Large Hadron Collider at CERN in Geneva. 27 kilometers in circumference. It's the biggest scientific experiment ever attempted, the biggest scientific experiment ever built. Its job is to take the nuclei of hydrogen, so the simplest element, single protons that make up the atomic nucleus of hydrogen, and accelerate them to 99.999999% the speed of light. Right? An immense number. That means, in more visualizable terms, that they go around this 27 kilometer ring 11,000 times a second. And we do